Good morning. As we wait for more people to come, I'll just introduce myself. I'm Sandy Wolfwood, a member of the Westminster's Eco-Justice and Social Ministry teams. The Social Justice Forums are built around a common theme in this program year. The theme is moving from understanding to transformation, affecting change together, guided by God. Through these forums, we want to explore capabilities we need to build and norms we need to examine in order to be effective transformation partners in our community. This morning, we're pleased to welcome Dr. Ling, Assistant Professor in the Civil Engineering Department of the University of St. Thomas. Ali's research seeks to better understand societal impacts of engineering solutions, and Dr. Ling's work has focused on water and wastewater treatment solutions for clients across municipal, mining, and manufacturing sectors. Her presentation today will provide a basic understanding of issues and solutions for environmental PFAS contamination. You've heard about it in the news quite a bit. A brief summary of PFAS sources and the current regulatory status of PFAS in Minnesota. A discussion of potential environmental justice issues associated with solutions and actions we can take. As we go through her talk, Ali has said that she's happy to take questions while we do that as opposed to leaving them to the end. So if you have a question you don't understand or something you've heard in the news about PFAS occurs to you, please raise it and Ali will address it. So before we get started, a couple of items. For those attending in person in the Meisel room, raise your hand and we'll bring a microphone to you all, including those on the live stream, can hear your question or comment. For those attending on the live stream, please submit your comment or question in the live stream chat and we'll monitor that and raise your question and comment. As a part of our ongoing effort to promote respectful conversations around concerns in our community, the social justice team has established guidelines for the social justice forums that you now see on the screen, or will soon see on the screen. Please take a minute to review these. I have to do that. There we go. Thank you. And before we get started, a short prayer. Let us pray. Breathe into us today a spirit of curiosity and humility. Help us engage with mindfulness, following the lead of voices from our community, and guide our speech and our self-awareness. So now, please welcome Dr. Ling for today's forum.
Thank you, Sandy, and thank you all of you for being here, both in person and online. I am going to talk about these forever chemicals, or also known as PFAS. You may have heard about them in the news. I just want to say that my space is mostly in science and engineering. I'm very much a learner in the area of social justice, so I'm going to talk a little bit about what I know, and I'm interested to hear your questions and your concerns and more about what you know too. So the things I'm going to talk about today, I'm going to start with what makes PFAS unique as an environmental hazard. There's been a lot of environmental things that we've dealt with over time, but I think PFAS has some very unique characteristics. I'm going to talk a little bit about my research in thinking about the costs of dealing with environmental PFAS. And then we'll talk about the regulatory status of PFAS in Minnesota right now and some potential environmental justice concerns. And then I was told to leave you all with homework, so we'll have some future needs and action items at the end. Okay, so what's unique about PFAS? I'm hoping to not give you all terrible flashbacks of your high school chemistry classes, but I do want you to feel empowered to kind of understand what this means. So PFAS are per- and polyfluoroalkyl alkyl substances. So what that means is there can be any number of fluorines, that's the fluorinated part, any number of fluorines attached to carbons in generally a long chain chemical. So when you have a fluorine, an F, attached to the carbon, that is the strongest bond in chemistry. It's very difficult to break that apart. It takes like the energy of lightning to break it apart. It also means that it's really soluble in water. So when it gets in water, when it gets in the groundwater, when it gets in the oceans, it travels kind of all around. So it is very persistent. There's no known natural degradation pathway. If you throw a banana out your window, like that's a little irresponsible, but that banana is going to be gone in like a week. If you put PFAS out in the environment, it's never going to go away. which means that it's very difficult and expensive to remove from the environment once it's there. And it also has an intergenerational justice issue of if we put these things in the environment and we're mostly thinking about what happens to us now and not thinking about what's happening to future generations, they're going to compound and compound and compound, and there's going to be issues for future generations. Now, the same chemistry that makes them persistent and mobile also makes them really useful in products and manufacturing. So these things came out in kind of the 40s and 50s. I'm sure I used to have Teflon pans. I'm sure you've all had Teflon pans. You know, if you use Scotch Guard to make your stuff waterproof, those were some of the earlier applications of PFAS. But they're used today in so many products, which means that removing them from those products is going to be complicated. It's just not just a matter of throwing away all our Teflon pans. It's a matter of going through the entire supply chain for all the products we use day to day and figuring out where they're used and where we can phase them out. The other thing about PFAS, so it's per and polyfluoroalkyl alkyl substances. That's the PFAS. So substances, there's a lot of these. There's over 10,000 of these types of chemicals. And so one of the challenges with that is they're difficult to measure and regulate. There's certain chemicals that we know a lot and that have been regulated, but manufacturers have, when something is regulated, they often are just switching to another type of PFAS that does similar things, and we just don't know as much about its toxicity or what potential harms it could be. So they're really difficult, both from a scientific standpoint, but also from a policy standpoint. And there's a lot of uncertainties about compounds that are not well studied. So there's so many of them, we don't actually know how toxic most of them are or what are going to be the issues. So some potential social justice impacts from these three characteristics. The persistent and mobile thing, it affects people worldwide. PFAS are present in the blood of basically every human being on Earth. It also compounds and affects future generations, as I mentioned. And the fact that they're so ubiquitous in our consumer products means that it's really difficult to choose your exposure level. You can't decide that, I'm not going to get exposed to PFAS because it's everywhere. And then also that if you did want to start buying PFAS-free options, they're often more expensive than the standard options that have PFAS in them. So I'm going to talk a little bit about each of these individually before we go into the next topic. So thinking about persistent and mobile, this figure shows kind of how they move around in the environment, and there's three main sources. So the first is that companies make PFAS, and then they sell them to other companies that put them in their products. So the production and manufacturing in various factories, PFAS can get into the environment either through the stat gas or into the water from there. And then once they're made, we use them. We can use them in kind of commercial uses or in household uses or in other places in the workplace. And from there, those can get into the air and water as well. And then once we use stuff, we typically will throw it away, we'll flush it down the toilet, and then it goes to waste management. So about 50% of the PFAS we use these days ultimately ends up in landfills. And so that's kind of, we think of that as a way, and then most people just stop thinking about it. But those landfills, there's liquid coming out of the landfills. How do you manage that liquid? How do you make sure that those landfills are staying sequestered so that they're not impacting future generations? Thinking about the use and ubiquity, this is a photo of stuff around my house that I picked up in like 30 minutes of just wandering around, of the types of things that contain PFAS in them. So there's carpets, there's cosmetics, there's paper, there's plastics, a lot of metal finishing uses PFAS, semiconductors and electronics, they're used in a lot of wires, in a lot of processors, in computers and things. Most fabrics have PFAS in them. Originally it was to make them water repellent, but it makes manufacturing most things easier. Things not included in this photo, building materials, so siding, carpets, flooring, outdoor equipment like my tents and my rain jackets and that kind of thing. And then a big thing is food. And you can get PFAS in your food. It can come from the soils because it's in the atmosphere and then it gets onto the ground. It can also leach from food packaging. That has PFAS on it. Any sort of paper packaging that's coated, it's typically coated with PFAS unless they're trying to make it not PFAS-y. And then food packaging. So there's been a lot of talk about PFAS in drinking water. For the average American, it only gets about 20% of their PFAS from drinking water. The other 80% is mostly from food that we eat and from dust that's in our houses and workplaces that we inhale and get it into our lungs. So drinking water is easy to regulate. The EPA just passed some drinking water regulations that are going to affect between 20 and 30 cities, probably in Minnesota. But regulating all of those other things upstream, all of the different things that we use PFAS in, is going to be important to reduce the PFAS that we're getting in through our food and through that dust inhalation. Okay, the third characteristic that I talked about is that there's just so many PFAS. So there's tens of thousands. There's not going to be a test on this, but this is kind of like the family tree of different types of PFAS. Most of them we hear about is in this one small family of the family tree. So has anyone heard of PFOA or PFOS? So those are the ones that are kind of the legacy compounds that were initially made. They're not made in the US anymore. Those PFOA and PFOS are members of this family, and they each have 8 carbons on them. So those were the original ones made, and then they were subsequently banned in next decades. A lot of companies changed to using, instead of the C8, the 8 carbon ones, they changed to using the C6 or the 6 carbon ones, which we're recently learning also have toxicity and other impacts. And so this is kind of the effect where you ban one thing, they change and make other chemicals. So the fact that it's such a big family of chemicals means that it's difficult to regulate, and there's so many different factors of the chemistry that affect how they behave in the environment and how they behave in our bodies. So there's a picture of PFOS. I also mentioned it's hard to measure. I'll talk a little bit later about the low concentrations, but because it's hard to measure, it means that most of the data that we have on how toxic it is, how we treat it, and how it moves around in the environment is for things like PFOA and PFOS. But we don't know that much about, the 99% of that big family of chemicals. The other thing that's challenging when it's difficult to measure is it's hard to close the fluorine mass balance. And what that means is that if you're studying a system, let's say you're going to a factory where they make PFAS and you're trying to figure out where is it all coming in and where is it all going out, we can't actually answer that in a lot of situations because they're often present at such low concentrations, and we do not have the types of machines that can measure all of the different forms of fluorine that it could end up in. And so while it would be nice to know exactly where it goes in all of these situations, we don't have the capabilities to do that at this time. So some of the issues here are like how toxic are all the other PFAS? We don't necessarily know. There are some ways to predict how toxic something is based on the chemistry. And then we also don't know how much PFAS comes out of things like incineration stacks. Okay, so that's kind of the intro of what PFAS are. I want to give a quick introduction to some of my research, which is related to this intergenerational justice of the PFAS building up into the environment. So I talked about persistence and mobility as a characteristic. To me, persistence is one of the most concerning issues with PFAS, even more than toxicity, and here's why. If we think about the global amount of PFAS in the environment, and we've got emissions going on, it's going to build up and build up and build up. And so those constantly increasing mass in the environment there's going to be more and more PFAS in the environment. And that leads to the potential to exceed both known health impacts, but also unknown health impacts. So at some point, it almost doesn't matter how toxic they are. If we keep making them and adding them and adding them and adding them, if we want, let's say we want people to live on the earth forever, these compounds last forever. So if we keep putting them in there, eventually they're going to get to the point where there's enough of them in the environment that they're going to be toxic. So that's kind of this intergenerational justice issue that is associated with this persistence. So the metaphor I like to use for this is a bathtub. If we imagine like all the PFAS in the world that's out in the environment as water in a bathtub, and the emissions coming out are the tap. Right now, there's a lot. There's a lot of PFAS being made and put into the environment. And then the drain on the bathtub is like active treatment and destruction, where we're removing PFAS from the environment. No, that's currently very small. It's about less than 1,000th of how much PFAS are being removed from the environment because it's so difficult. So what I've been thinking about is a steady state situation. If we want to get to a point where there someday are less PFAS in the environment than there are now, we need to get to a point where we're taking out the same amount that we're putting in, right? And there's 2 ways to do that. We can either increase the treatment to match the emission so that we take the same amount we're putting in, and now we're going to spend a lot of money and treat it at that same rate so that the amount of PFAS in the environment stays the same. The other option is we can significantly reduce PFAS made, used, and emitted. I'm going to argue strongly for that option, and here's why. In my recent research, I asked this question of how much would it cost to increase treatment and destruction from the environment at the same rate we're putting it in. So how did I do that? I estimated how much PFAS we're currently putting into the environment. It's on the order of millions of tons per year. And then I looked at what sorts of technologies are currently available at a large scale where you could remove that much PFAS from the environment. And then I looked at how much it costs to destroy it from the environment, given those technologies. And then I multiplied those things. So emissions, how much PFAS we're putting into the environment, and then at how much it costs per amount to remove it from the environment. That gets me to an estimate of how much it would cost to have that bathtub be balanced, where we're now taking out as much from the environment as we're putting in. And that cost exceeds the global GDP by several orders of magnitude. So what that means is there's not enough money in the world to remove PFAS from the environment as fast as we're adding it right now, and it's not even close. So here's something to think about here. If we think about how much it costs to buy PFAS from a store and do whatever you want with it, it's typically around 20 to 1,000 per pound of PFAS. It depends on what product you're going to do. If we're talking about how much it costs to take PFAS out of the environment and destroy it, it's more like $1 to $65 million per pound of PFAS. And that's a big mismatch. It costs a lot, and those costs to remove PFAS from the environment are often borne by society, by taxpayers, or they can be borne as health impacts, health costs by society. So this to me is really concerning, that there's a problem. Yeah. Yeah. Okay. Oh.
So I live in the Cottage Grove, Woodbury area.
Yep.
And I'm one of the park teachers of many of us. There were 12 in a short term that all got cancer.
Okay.
So I've done a lot of research. There was
Yeah.
an article in the Star and Tribune last Sunday. I don't know if you saw it.
I didn't.
And I've been cutting them out.
Okay.
My understanding, and reading many things, my understanding is there a way to even destruct this?
Yes, there is.
Okay, because my understanding is 3M is having a plant or some way to do this.
Yep.
And then there wasn't a lot of money. I want to say maybe they put aside 8.5 million
Yep.
within the state to get rid of this on top of what they're having to do the wells.
Yeah.
But again, my understanding is it's very difficult to destroy it.
It is difficult to destroy it. So the most common way to destroy it on like a big scale is to heat it up to like 1,000 degrees Celsius. That's like twice as hot as the clean cycle in your oven. It's really hot. But there are a lot of technologies coming out today, including ones that the Minnesota Pollution Control Agency has been testing to destroy it. So typically what you need to do is it's present in very, very small concentrations in the environment. And so you need to concentrate it into a smaller volume. And then once you get that, you can put it through another type of technology that either some combination of high heat, high pressure, adding some types of chemicals, making it more alkaline, adding some electricity. There's a bunch of different ways that you can destroy it. And so there's a lot of technologies that are coming online that are being tested. And I think those are really promising and really helpful in targeted places like the East Metro, where there's a lot of PFAS in the groundwater. I don't think they're practical for managing the total amount of PFAS in the environment because that number is just too big. Yeah. I think question over here too.
So it takes a lot of energy, more energy to destroy it than make it. And the balance, I mean, you've got that. My question is, once it's destroyed, is it then neutralized in terms of its environmental threat?
Yeah, so you can fully destroy it. It's, remember those long chains, which are mostly carbon, hydrogen, and fluorine. You can destroy it to like break it up into its individual elements. So then you end up with carbon, CO2, water, and then fluorine present in the whatever.
Is it entirely man-made or does it occur naturally?
It is, PFAS are entirely man-made, yeah. Yeah.
I think I missed something early on. This mention of cancer says that's one of the physical toxicities. What are the other toxicities of this PFAS?
Yeah, and just to caveat, like the health effects, it depends on how much you get in your water and all of the other things. some of the health effects that have been shown for certain types of PFAS, increasing certain types of cancers, liver dysfunction, thyroid dysfunction, lack of immune response. So some people you can get a vaccine and maybe your body doesn't respond as well and give you as much immunity as you would if you had lower concentrations of PFAS in your blood. But one of the complicating things about this and about a lot of environmental health things is that all of us have PFAS in our blood. It's a matter of how much do we have and which PFAS are going to affect those health impacts.
You talked about the products that have PFAS, Scotchgard, Teflon,
Yeah.
but you also talked about manufacture of PFAS that then these other companies use to put on the products. So there are companies out there that are still manufacturing PFASs to be used on products by other companies? Is that right?
That's correct. So PFAS manufacturing is currently done by about between 20 and 30 companies in the world, including 3M, including Chemours, which used to be DuPont, including Dow Chemical, and Daikin. Those are kind of some of the big names in the U.S. 3M has committed to stop making PFAS sometime next year. So that's a big thing. It would be really great if other manufacturers stopped doing that. But yes, so there's a limited number of companies that actually make the chemicals, but then those go out into our supply chains and are used throughout our supply chains in a lot of other different components. Yeah. All right. Any other questions at this point? Okay, so I'm going to talk a little bit more about what we need. So because we're making so much more than we can take out of the environment, what we need to restrict how much we're making and using. So PFAS use restrictions. And I'm going to list here some things that I think are important for this type of policy. The first is that they're nonspecific. They should target persistent PFAS as a whole class of chemicals, not just PFOA and PFOS in some limited number, because targeting just individual chemicals means that the chemical companies can just pivot and make different types of PFAS. The EU has proposed restrictions like this, and Minnesota's ban is like this as well. It bans all PFAS. Betty McCollum just introduced this week legislation at the federal level that would do something really similar, which is super exciting. The other thing that it needs to consider essential use considerations. So I would love to be able to get up here and say, I think all PFAS use should be banned and outlawed tomorrow. I don't think that's something that we can do. PFAS are used in semiconductors. They're used in a lot of medicines and medical applications. So I think any PFAS use restrictions needs to include, the word is derogations, but they're essentially exemptions or temporary exemptions to limit immediate economic and societal impacts of these bans. Most PFAS that we use can easily be changed out for different chemicals. But there are some places right now in our society where we use PFAS where it saves lives. And I think we need to keep using those for now and keep researching how we can phase those out over time. But I don't think we can ban them all right now. But they do need to be evolving. So I think that involves ongoing reevaluation of those essential uses and investing in chemical engineering to develop non-PFAS alternatives for those things that are considered essential. And so the Minnesota law here has, by 2032, it's going to ban all PFAS that are not currently unavoidable. And that's kind of related to this. So deciding which things are currently unavoidable or not is going to be a very important step in enacting these types of laws. The other thing about PFAS use restrictions is ideally they need to be global. Because they're so mobile, they move around in the air, in the oceans. Certainly, certain countries can be leaders and pass these first, but ultimately we need to ban PFAS at a global level. Okay, so where are we in Minnesota? So Minnesota, not this winter, but last winter, passed this legislation. It's called Amara's Law, named after Amara Strand, who is a young woman who died of cancer in the East Metro area. And here's what the ban does. So at this year, it bans intentionally added PFAS in food packaging, which is a big source of how we get PFAS into our bodies. By the beginning of next year, it bans intentionally added PFAS in 11 other product categories where there are readily available alternatives. So in those product categories, those companies should pretty easily be able to go out and find things that don't have PFAS in them to use. It's going to require additional reporting on PFAS in products so that the PFAS that are not intentionally added, companies will understand what those are and can work to phase those out. And then by 2032, it's banning PFAS in other categories that are not currently unavoidable. The nuance here I see is it bans intentionally added PFAS. Most PFAS are probably not intentionally added. There are certain applications like the nonstick cookware or like waterproof stuff or greaseproof stuff where people are saying, okay, we want PFAS in our products to provide this level of performance. But a lot of companies are just buying what's out there on the market, and a lot of the stuff that's out there on the market to put into their products has PFAS in it. So one example from Keen Footwear. Keen is a kind of a leader in the US in terms of phasing out PFAS. They phased out PFAS about 6 or 7 years ago. So they went through their supply chain. They mostly make footwear, but also some like bags and other things. When they went through their supply chain to try to figure out where PFAS was coming from, they found 100 different components with PFAS in them before they phased it out. And they were very surprised to find that many. So they had to go through each one and figure out, where's the PFAS coming through? Is it from our primary supplier? Is it from their suppliers? Is it further down up the stream? And figure out alternatives, either working through those suppliers or finding different suppliers before they could phase them out. And then they also do ongoing testing, random samples of their products at all the different phases of the production to figure out, is there PFAS coming in from somewhere else? And sometimes they'll find it. One time they found it like in some receipts that were packaged in the boxes with the shoes, and that was getting onto the shoes. And so just like this intentionally added thing, most of them are not intentionally added, and there's going to need to be ongoing vigilance for contamination from other places. Okay, I'm going to talk about drinking water now, but I do want to give you a little aside. So the concentrations at which these are regulated in drinking water are parts per trillion. And so that means it's a drop. A part per trillion is about a drop in an Olympic-sized swimming pool. It's about 9 hours as a fraction of the age of the whole Earth, right? The Earth is 4.5 billion years old. The other one I came up with this morning is if you got every person in the globe in a room and like weighed them, it would be like one person's finger in relation to the weight of all humanity in the whole world. Okay, so parts per trillion is a very, very low concentration, and that's part of the reason why they're so difficult to measure. They have been found, so PFOA and PFOS have been found to have health effects at these low levels, which is part of why we've been measuring them at these low levels. So the national guidance that was published earlier this month for drinking water, these are the first official drinking water limits for PFAS at a federal level. And they're at parts per trillions. It's be either 4 or 10 parts per trillion, depending on the compound, for 6 specific PFAS. Recent monitoring suggests about 12% of U.S. water supplies exceed those values. Current numbers are sometimes, you'll see things up to maybe 25 or 30%. Not all water supplies have been tested, so we don't actually know, but it's probably somewhere between 10% and 30% of U.S. water supplies would need some additional treatment to remove PFAS from their water. And estimated about 23 Minnesota cities have PFAS above the MCLs. Some of them have already been putting in systems. So Woodbury, Cottage Grove, Bemidji are some of them, Oakdale, that all have systems in place and have plans for removing PFAS. But a lot of those other ones do not currently have a system in place, and someone's going to need to build it and pay for it. Okay. Any questions about the regulatory status in Minnesota?
So being from those areas, and I got cancer a second time
Okay.
after 17 years. And the first cancer, it's not in my history, wasn't in my genetics, wasn't supposed to get it again. Asked my oncologist, okay, what's the deal? I taught at this school for 4 years in Cottage Grove and lived in Woodbury. He said it was a different cancer.
Okay.
Then when I got it in 2019, I'm wondering, even with the girl, I saw her on the news, I called the CDC and said, okay, how about a blood test? Is there a way to determine with PFAS or PFA? I knew we didn't have the O's anymore. Can you test my blood? Can we do a baseline now that I'm still living in Woodbury and you haven't done anything with the wells, because they finally did shut down 7 wells. And we have the best filtration system. We have a double one on the house I own.
Okay.
And it wasn't charcoal yet. Okay. Charcoal is the only thing I know that filters this out. I asked, is there a blood test that we could see PFAS in your blood? I mean, how did they because I want to know, is mine going up or down? You know, even with them now changing the amount that they could have, they said the wells were fine, and then they found out, no, they were over. You know, and they said, oh, a blood test would cost too much. There's no way to see PFAS in your blood. Is there a way to see it?
Yes, there is.
And then is it expensive? And then how did they find it in the girl that died?
Yeah, I don't actually, about Amara Strand, I don't know very much about her case, so I can't speak to that. There is a way to measure PFAS in blood, and there is data out there in terms of people's, in certain areas. I know that in the area around, I think in Wilmington, North Carolina, they did a lot of testing of people with, and to see how much PFAS was in their blood. That was where there was a DuPont factory making this new PFAS chemical, Gen X. I guess I'm a little surprised that they haven't done much of it here. But there certainly is a method. It is expensive. I don't know how much it costs to measure PFAS in your blood, but if you want to take a water sample from the Mississippi River and measure PFAS in it, it's about $700 per sample. And so if you were doing that in a clinical setting, I'm sure there's additional fees and other stuff associated with that. So it is available. It is expensive. And you mentioned the charcoal. So this picture here, this is what a drinking water plant for PFAS looks like. This particular one is not for PFAS, but this is the technology they use. So these are tanks that each hold 60,000 pounds of what's called granular activated carbon, which is basically a fancy charcoal. It's charcoal that has been heated in a certain way so that there's a lot of surface area on it. It looks like black sand, but if you have a teaspoon of it, the surface area is more than a football field. There's a lot of little pores and stuff in there, and then it's really good for stickiness, PFAS, and then you have to, once it's used up, you have to either change it out or regenerate it. So if you see these, those are the little people in the background, so you can see how tall these are. If you wanted to treat, a city like Woodbury, I know they've got systems like this, but it's 10s to 20s to 30s of these types of tanks present. It's a big system. Question over here.
About regulation, you want to know if there are other questions. So you can regulate, discover a level that's not safe and regulate against water sources that have that level and or the production of those. But who then, cities redo their water systems over time. I mean, this should all be part of social engineering or civil engineering, right? But given, for example, here in Minnesota, there's high levels found. Is the government responsible for that? Is the industry responsible for that?
In terms of the cost?
I mean, it isn't, I don't want to reduce it just to cost because it's also policy.
Yeah.
And mutual understanding is what policy is about. And like you said, so, I mean, it's good for some things and bad for others. I mean, there's judgment involved.
Yeah.
But essentially, it's going to get reduced to the crisis of finances
Yeah.
because that's just how we think, unfortunately, or fortunately, as the case may be.
Yeah, it's a really good question. So in Minnesota, the Minnesota Department of Health is going to be responsible for enforcing these federal limits. And they've been tracking PFAS in drinking water supplies for several years. In terms of the cost, I don't think we know who's going to pay for it. There was a 3M settlement for the East Metro groundwater that supported both Woodbury and Cottage Grove systems. So those systems were mostly paid for by 3M, along with some state funding. Other cities, I don't know exactly what's going to happen.
And then once it's removed, it has to be destroyed, and that's.
Exactly,
Is
yes.
that included already in the regulation?
It is
process?
currently not. So the EPA, they passed these drinking water regulations. They did two other things in the last couple of weeks that I think are related to this. One is they included those two PFAS, PFOA and PFOS, as hazardous substances under a regulation called CERCLA. And what that means is that it's better known as the Superfund Act. So what that means is it opens the door for more action that could be taken against polluters to get compensation for those compounds. There's a lot of discussion out there as to what that's going to look like financially. The other thing that the EPA did recently is they put out updated guidance about how to they don't say destroy, they say disposal of PFAS. And a lot of that guidance includes putting it in landfills, not necessarily including ultimate disposal. So again, it's a cost issue. It's, putting it at landfills, it probably costs about, $60 to $100 a ton. If you're going to destroy it, the current cost for that is more like $1,000 a ton. So it's a factor of 10 in terms of costs of how to dispose of it. I don't know what the existing systems that are planned right now are planning to do, but I think that is a question that's going to have to come up as people build these types of systems, is what are we going to do with it once it's done?
Is there disagreement about the facts and what's party here, or like here in Minnesota, we see the problem and are working to fix it, even though it's a very difficult problem, or are they arguing?
Yeah, you're asking about whether there's disagreement. I mean, I think there is. I don't think the EPA has set a standard for how people should be disposing of this. In terms of, I think there's a general understanding that this thing disposes of it finally, and this one doesn't. But there's a lot of feeling that when you put something in a well-designed landfill, it's not going to come out as long as before society collapses, essentially. So I don't think one of them is like the right answer at this point, especially given the finances. But it's a challenge that we're going to have to work through.
I don't recall what the paper said last week, but if you look at the Sunday Star and Tribune, that point was in there. And one of the point that was in there was the amount of money. And, okay, what are they going to do now that they got to figure out what's going to happen when they get rid of it? And that was part of the discussion, because there's only so much. They didn't talk about now what's going to happen when they get rid of it. And I don't know, in your talk, my big thing too is wondering what can we do in our homes.
Yeah, that's going to be at the end in a little bit.
I just want to make
I'll get
sure.
to that. Okay, so that's kind of, now you know a little bit about PFAS, a little bit about how they're regulated. I want to talk about some things related to justice here. So this is a paper that came out last year, and these folks studied different communities, and they tried to understand how many which types of communities had more of the different sources of PFAS. They specifically looked at airports, industries, and military sites, which are historically sources of PFAS to the groundwater. So they found that communities with higher percentage of Black and Hispanic people had significantly higher amounts of PFAS in the water and were significantly more likely to exceed the standards that are now being set. So it was something like with each % increase in Black people in your community and Hispanic people in your community, you had something like a 5% increase in likelihood that you would exceed the MCLs. So when we get back to costs too, this is a huge issue. If we are taking these chemicals and then the cost is going to fall disproportionately on communities that have been underserved in the past, that's a huge issue. So this gets kind of to your question, is who's going to pay for the treatment? There's additional monitoring. As I mentioned, testing for these costs about $500 to $7 per sample. And then the systems are expected to monitor, design, and construct a water treatment plant in 5 years. Now, that sounds like a long time, but as a civil engineer, I can tell you that from the moment you say, I'm going to build this plant, it takes 2 or 3 years to build it. So they're going to have to do the monitoring pretty quick. They're going to have to figure out what they need to build and then get started breaking ground here probably in the next few years if they want to be in compliance in the next 5 years. So this is, in terms of this drinking water law, this is one of my biggest concerns, is who's going to pay for it. And in addition to PFAS, there's all sorts of other drinking water concerns. Our drinking water infrastructure in the United States is aging, and utilities are going to need, aside from PFAS utilities need to spend a lot of money maintaining the water mains so that they're not breaking, maintaining the water treatment systems, managing other contaminants. And so there's other stuff that water utilities need to do. So the question of how they're going to add on to this, I think, is still yet to be answered. I hope that it doesn't fall on taxpayers and ratepayers and increased water rates, especially in disadvantaged communities. Okay, another thing that I think is related to justice is there's a lot of PFAS-free brands out there. I'll show you a website at the end that you can look at. But a lot of them are more expensive than the brands that have PFAS in them. So people can choose to buy things that are PFAS-free, but it's often at a higher cost point. Two outliers, H&M and IKEA, are two potential outliers that are a little bit more affordable and are PFAS free. But I see that, at least in the near future, before these blanket phase outs happen, there is a justice issue in that PFAS free products are generally more expensive. The third justice issue I want to talk about is this destruction. So current large-scale facilities for PFAS destruction are typically these high-temperature incineration facilities. There's about between 10 and 15 of them in the United States that burn them high enough to destroy PFAS. It's not just any incineration facility. But the question of who's affected by these emissions and how do we track their performance, as I mentioned, we do not have the analytical capabilities to definitively say that there is no PFAS in the stack gas. People have measured the PFAS that are easy to measure, and they see like 99.999% reduction in the PFAS that we measure, which is great. But we don't have the ability to say that all of that is going to elemental fluorine and not to something else. So one thing that's happening is that we're moving more towards non-thermal technologies that don't have those air emissions. So these might be, instead of something you burn and then there's a stack emission, it might be something that you put like a liquid through and then it destroys it and what comes out is a clean liquid and there's not stack gases. I see there being less environmental justice impacts with that type of technology. And those types of technologies are rapidly coming online and scaling up and getting applied in more places. So what do we need as a society? To me, this restricting the use and manufacture of PFAS is number one, the most important thing we need to do. These are the three things I talked about with essential use considerations: non-specific, targeting PFAS as a class, evolving, and then global. And then applying these over time on this type of global setting. The other thing I want to say is that what do we need as a society? We need to recognize multiple environmental risks. I'm not going to stand up here and tell you that PFAS is the most important environmental issue of the day. It is not. So we've got climate change mitigation, we've got adapting to changing weather, we've got air and water quality, pesticide and herbicide use, preventative and restorative health in our communities. There are a ton of other environmental problems. And so one of the big challenges I see in environmental engineering and environmental health is getting a better understanding of how all of these different risks connect to each other and what are the risks that are most important that we can manage. So PFAS in water is something that we can do. It's very expensive. Are there other ways that we can spend that money to manage health risks in a different way? And I don't know the answer to that, but I think kind of looking at environmental health as a holistic thing and not just at was one or two problems that we see, I think that's something that we really need. The other thing I want to mention, this is kind of related to that intergenerational justice, but the great law of the Haudenosaunee Confederacy, which is an indigenous group, has a 7th generation principle. So they say that today's decisions should support people 7 generations in the future. And I think that as people living on this earth, we need to care about our grandchildren's grandchildren's, and we need to make their well-being just as important in our decisions as our well-being. I think it's easy in today's society to like, you got to meet the quarterly budget sheet, you got to do this and whatever. We all have demands. But if we can think of those people 7 generations from now and try to make their lives better with our actions today, that's going to make a big difference. And I see PFAS as a really great example for that because they don't go away. So we can, with PFAS, we can do nothing and just go on as we are making and using PFAS and putting them out there. Or we can advocate for and put out these PFAS bans to better protect people 7 generations from now. You have a question here.
Thank you. And just a strange thought, there's no talk of recycling them like we recycle plastic.
You know, that is a good question. And I think there is a little bit of talk. I think there's the extreme challenge there is that they're usually present both in products and in the environment at such small quantities. So those manufacturers that are making PFAS, they're selling PFAS like in a jug. But as it goes through the supply chain, it gets more diluted and it gets used even in our products. Like there's very little PFAS in there, but because they can have potential health risks at such low levels, like that's an important amount, but it's really hard to take those and then concentrate them back up to use them again.
So a follow-up question, is there, along with the discernments that you've described, does this lead to like a change in how we view nature? I mean, you know what I'm talking about, the Anthropocene and the man-made and it relates to your environment, climate change and all that. I mean, is there really some way out?
Yeah, I don't know. To me, like, I think there's hope here. Like, I see this type of thing, and I see that there's hope. When you look at the environmental things and how people have changed and how they think about the environment, even in the past, 50, 60 years, there's been a huge change. I think, like, going back to indigenous knowledge, like, they thought about the earth in a way that was very responsible and took care of future generations. And I think bringing more of that into the modern mindset is something that we could all benefit from.
Knowing you're a civil engineer and you're not medical, but the medical piece of the health definitely ties in. Have you incorporated, I mean, there's tons of things out there about the impact of PFAS on people. And I know you speak of the indigenous. I know, and I was talking with these women, the Native American women of Alaska in the 60s, they found the impact of PFAS from those women way back. And there was hardly any health issues with them. And they found that when there was PFAS there, have you incorporated anything of how PFAS has affected health or have any of that kind of research?
Yeah, that's not, I am not planning to research that. I'm a follower of that type of knowledge because I think it's really important to some of the conversations and the plans we have about taking it out. So I don't plan to get into that area very much. But I think when we do think about like the risks and balancing those risks, I think there is going to have to be conversations between environmental health and environmental engineering folks to figure out like what are the priorities if we think about environmental health as this whole big thing that affects people in a lot of different ways, and then how can we engineer things to mitigate those risks.
I have a question, going back to your comment about Betty McCullen's bill has been introduced. That's great. It was good to hear that. And if, as we think about that, I'd like to know what can we do about that as a group, as a church to support that? And how do we advocate for that? And then find out from you, what are the pushbacks on policy level? Is it
Yeah.
only from the companies? Or are you getting that from Congress people that have these companies in their districts?
Yeah, good question. And I'm going to move forward to what can you do? Yeah, no, that ties into this really, really well. So I was told to give you homework. So things that you can do on an individual basis, buying less is always a good thing. But when you do buy new things, see if you can choose PFAS-free when you're buying. So you can research and support PFAS-free companies and products. This link here, this is a group called the Environmental Working Group. If you Google them and Google Environmental Working Group PFAS-free products, they have a nice list of brands that have PFAS-free things. You can also ask your favorite companies why they're not on that list. I think that's a meaningful way to help push that things and then hold the companies accountable. In terms of your exposure, we mentioned drinking water is maybe 20% of the average Americans, but then there's also the food and the household dust exposure, and those are things that you might be able to have more control over. Again, I don't think it makes sense to throw away everything that has PFAS in your house because it's going to be, like from an environmental standpoint, you're going to have to buy a lot of new things too. But when you do buy new things, buy PFAS-free, protect your family, PFAS-free cosmetics, ceramic or cast iron cookware, eating organic when you can. Pesticides are a big source of PFAS. Whole foods to avoid packaging. And then if you're going to store food in your fridge, using glass or metal containers rather than plastic or paper containers, which are more likely to have PFAS. And then support policies restricting PFAS. So I think being patient as Minnesota's PFAS ban rolls out, supporting the federal ban, learn about PFAS in your workplace supply chains. If you work somewhere that might use PFAS, try to ask about what people are doing there. And asking federal government officials to advocate restricting PFAS products as a class. I made the slide before Betty McCollum introduced that bill. So this is happening, but I think talking to them, giving your support, and kind of supporting those policies now that hopefully you understand why they're so important. The question of pushback and what sorts of pushback we see. There's a lot of pushback right now against regulating PFAS as a class. partly because, we know a lot about these types of PFAS and we know that they're hazardous. So there's generally agreement that yes, PFOA, PFOS, we should not be making those, and we're not already. But there's other types of PFAS that are more stable. So one example is fluoropolymers. So like the PFAS in your rain jackets, it's called the fluoropolymer, and it's present as it's like a plastic, and it is pretty durable. It's not going to like break down in the environment. So when that goes into the landfill, it'll probably be there for a while. They do break down over time eventually, and then there is some PFAS emissions potentially as they're made, but right now there's a lot of pushback about PFAS as a class and which PFAS should be regulated and which PFAS should be not. There's also some pushback about essential uses, and I anticipate that being more and more of an issue as these bans roll out, in terms of deciding what uses are essential or what uses are currently unavoidable. In Minnesota, the Minnesota Pollution Control Agency, the MPCA, is responsible for making those decisions. So I think they recently had a call for public comment on what that currently unavoidable should mean. But over the next 8 years, they're going to be developing the policy about what sorts of uses are unavoidable and are in that exception. So I think following along with how that goes along and encouraging them to be strict in, not exempting things where there is currently available alternatives, while still exempting things that are important for health. It's a complicated issue.
Is Gore-Tex in using a PFAS?
Gore-Tex has a PFAS-free product, but they are not totally PFAS-free. So if you have Gore-Tex, you might need to figure out exactly which Gore-Tex water repellent product it is to know if it's the PFAS one or the non-PFAS one. Other questions? Why don't you wait here for...
Can labeling law, like we have
Yeah.
products that you buy off your grocery store shelf, there's a lot of labeling law involved. It sounds like we're just becoming aware of this, and this is really spreading fast. And of course, we have the means to spread this very fast. Is labeling laws, and so when I go to the store, I could look it up because I have a computer, but
It's a good question. I don't know very much about that. I think there is very likely a place for labeling laws so that people can go to the store and know, like, oh, this thing has PFAS or this doesn't. There are some like more general sustainability labels right now that include PFAS free, where if it has this label, it has all these other things and it's also PFAS free. I don't know what those are off the top of my head, but I think there is a place for that. I don't know how that's going to work. Other thoughts or questions?
I'll ask one more question. I'm a designer, and for years I've been surprised at how much impact designers could have on packaging.
Yeah.
It shocks me how packaging continues to be something that people put out there, plastics and now PFAS. And I don't know in the circle of folks I talk to that they're really getting much of this information, and they really can start pushing this. How have you seen this communicated to people who could actually have an impact on this kind of stuff?
Yeah, that's a really good question, and that's a topic that I'm very excited about. I actually am working with a couple folks in the Opus College of Business here at University of St. Thomas. We've just started talking about this, but trying to figure out how to provide more guidance, both on the product design side, that's kind of like the intentionally added PFAS, but also on the supply chain side in terms of packaging, in terms of other PFAS that might be not intentionally added, how we can help spread the word in that community and come up with tools that those types of companies can use to better understand PFAS use and come up with tools to identify alternatives and make those phase outs happen. So I'm really interested in that area, and I'm hoping to have more to share in a year or two.
I think we're closing in. Do you have anything else to say?
I don't know.
Are there other questions before we close up?
What can we do at home? Like, we're wondering, what my husband was also wanting me to ask you,
Yeah.
get a charcoal filtration system on our water? I mean, what's the best?
Yeah, for drinking water, the two leading things that you can do in your home are either a granular activated carbon or GAC filter or a reverse osmosis filter. So reverse osmosis is it's used for like seawater desalination. It basically takes everything out of the water, including PFAS. The granular activated carbon filters also work. The complication with that is that you do need to change those out because that carbon gets full of PFAS, and if you keep running it through, then that PFAS is all going to come out too. So you can buy either point of entry units, which are in your basement close to your water meter, or point of use units, which are like under your sink where you're using it. And I would look for reverse osmosis or granular activated carbon.
Well, we'll have to end it there. Allie will be here if those of you in the room would like to chat with her. Thank you so much for being
thank
here.
you.
That was rich information. I was taking notes. I'm going to write an article for our newsletter. This has to get out there. So next Sunday, we welcome Catherine Allen Halverson. She's a Westminster member and the staff attorney for the ACLU of Minnesota, speaking on balancing parents' opt-out requests and LGBTQ rights. So we'll look forward to seeing you then. So come back. Thanks
Thank you.
again.
That was great. Okay.